March 31, 2026. A specific version of a widely used development tool, Claude Code version 2.1.88. A critical vulnerability emerged days after a source leak. This is not a standard software patch. This is a fundamental shift in how we understand security for artificial intelligence tools. As senior engineers, we are used to managing risk through layers of protection. We are used to assuming that if the perimeter is secure, the inside is safe. But this incident challenges that assumption. It reveals a gap in standard security tooling that failed to detect an artifact hygiene failure. To understand the scale, imagine a warehouse. You ship a product to a customer. Inside the box, you expect the product. But instead, you also left the blueprints, the inventory list, and the keys to the factory. That is what happened with the npm package. A missing npmignore file meant 512,000 lines of proprietary code were public. Anyone could download it. This is not a hidden variable. This is the entire source tree. The npmignore file is a standard configuration file that tells the package manager which files to exclude when building a distribution package. When it is missing, everything gets included. This is a basic configuration error that would be caught in a standard security audit, yet it slipped through because the tooling was not designed to catch this specific type of supply chain exposure. What was inside? It was not just utility functions, it was the skeleton of the agent's logic, the way it talks to the terminal, the way it calls large language models. This was previously hidden behind a black box. Now it is open book. Researchers can see the exact prompts, the exact error handling, the exact pathways. This allows them to identify systemic flaws in how the tool handles terminal interactions. It allows them to reverse engineer the logic that was previously proprietary. This leak of 512,000 lines of TypeScript code exposed the internal workings of the system. Here is the thing about how we got here. We are seeing a shift to vibe coding. This is where artificial intelligence generates 100% of the contributions. The human writes a prompt, the machine writes the code. The speed is incredible. But the review process is not keeping up. Security tooling failed to detect the artifact hygiene failure. We relied on obfuscation. We thought hiding the code was enough. We were wrong. In a traditional development workflow, a developer might review every line before it ships. In a vibe coding workflow, the developer trusts the model to generate secure code. This trust is misplaced when the output is packaged without review. Academic studies on engineering pitfalls in AI coding tools have analyzed over 3,800 bugs in AI coding tools. They note that configuration errors constitute a significant portion of issues. This incident is a prime example of that trend, but it highlights a specific failure in the packaging process that standard audits missed. Standard machine learning operations defense in-depth architectures rely on layers. You have firewalls, you have access controls, you have encryption. But this was a supply chain risk. The artifact itself was compromised before it even reached the user's machine. This highlights a gap. Standard security tools look for malware or known vulnerabilities. They do not always look for missing configuration files that expose the entire source tree. This is a non-obvious trend where the rapid iteration of AI coding agents outpaces security review processes. The speed of innovation is valuable, but it is not a substitute for security. Another paper titled, "Just Ask, Curious Code Agents Reveal System Prompts in Frontier LLMs," focuses on system prompt extraction rather than source code exposure. While that research is critical, it does not corroborate this specific event. However, the broader empirical studies discuss general engineering pitfalls without confirming this singular high-profile incident. The consensus is that AI-generated code introduces novel security challenges, but the factual basis for this specific vulnerability remains unverified by the other cited academic research. This creates a leak, cheat, repeat cycle. Vulnerabilities are discovered and exploited before patches can be deployed. The brain of the agent is now exposed. If someone wants to exploit the tool, they do not need to reverse engineer the binary. They can read the source code directly. This is a critical liability for enterprise adoption. Future implications suggest that the industry will shift towards unpatchable or immutable security models for AI agents. Releasing complex command line interface tools with hidden logic is becoming a critical liability. The incident underscores a non-obvious trend where the rapid iteration of AI coding agents outpaces security review processes, creating a leak, cheat, repeat cycle where vulnerabilities are discovered and exploited before patches can be deployed. We need to treat AI-generated code with the same rigor as traditional software. Code review is not optional. Supply chain verification is mandatory. The consensus is that AI-generated code introduces novel security challenges, but the factual basis for this specific vulnerability remains unverified by other cited academic research. However, the broader empirical studies discuss general engineering pitfalls without confirming this singular high-profile incident. The key actionable takeaway is that AI-generated code and agents in release pipelines require the same rigorous code review and supply chain verification as traditional software. The brain of the agent is now exposed and can be reverse engineered for exploitation. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.